Hi everyone, welcome back. So as I mentioned in the previous videos that we are going to make a video series in which we are going to do some hands-on with the implementing artificial neural networks of different kinds with the help of Keras. And as you have seen in previous two videos of mine that we just don't focus on that implementation part of the neural network. We do an end-to-end process, end-to-end project. And in that end-to-end project, we play with the data set, we do the pre-processing, we do the evaluation of the model and etc. So for the case of RNNs, recurrent neural networks, uh, I have come up with a project on human activity recognition. So by the way, human activity recognition is my own area. I'm doing research in this area since last 2 years. And have made some contribution. So that's why I come up with this particular project. So for this project, we are making use of this particular dataset, which is Wisdom Activity Prediction dataset. It's a dataset from Fordham Lab Wisdom Lab at Fordham University, and it's one of like a benchmark datasets in the domain. So this dataset has the accelerometer data of smartphones, which were placed inside the pocket of the user. And after placing that, they were asked to perform certain activities like jumping, walking, sitting, sleeping, etc. And the target was that with the help of neural networks, we should be capable of classifying those activities, right? This is basically the target. This dataset has the raw sensor values of only the XYZ axis of the accelerometer present in the smartphone of the user. Okay, so let's get started. So in the Colab, we have IPython interpreter. The good thing of that is we can make use of Linux commands, right? So what I'm doing right now here is I'm cloning the dataset from this particular location, this particular URL. I'm using wget for that. After cloning that, I'm checking whether it's downloaded properly or not. So ls means list, show the list of the current working directory, and it shows me the two things. One is the folder sample data, and the other is the tar file which actually downloaded. So by the way, you need to put the exclamation mark before calling any Linux command. Okay. This folder is always present inside the instances created by the Colab. Okay, we do not need it right now. Uh, this is the tar file which we downloaded. After that, I actually again ran a Linux command to unzip it, and then I'm going inside the folder of it to check that whether all the files are present or not. Okay, one of the files is the important one. This is the file which we are going to make use of. Okay, so by the way, talking about the includes, so this particular notebook has gone through a lot of projects. So a lot of tinkering, experimentation was done on it. So you will find a lot of unnecessary includes here, but I'm going to highlight the ones which I'm making use in this particular video. So you can ignore these all, you can ignore these, etc. This is the one which is used, and I'm going to highlight these two are very important. They are being used. This is the one that is being used. I'm not sure if science stat is used or not. So I'm going to highlight what is being used and how that is being called. Okay. Okay, moving forward. So basically, you just need to ignore these three lines. What they're doing is they are just tinkering the way the output images are being displayed on the Colab. Okay, it doesn't have to do anything directly with the project. Okay. In the next line, I'm just printing the version of Keras. This is the way to print it. There are you write Keras underscore underscore version and then underscore underscore. So it prints you the current version of the Keras that is being loaded in this notebook. Okay, then I declared a variable that's name is label, and then I'm making it a list of all the activities that are present in the dataset. Okay, so I have gone through the documentation of the dataset files, and I'm going to tell you what things are included in the dataset, etc. as the video proceeds. Okay, talking about these two variables, they are very important parameters. So if you talk about human activity recognition making use of sensor streams, so what happens is that we are getting the streams of the data um, when the activities are being performed. So it's a continuous stream, but the problem is that we cannot give the continuous data stream to a neural network. A neural network has a fixed input size, so you need to fix the input size somehow. So what we do is, we in the case of RNNs, or even in the case of CNNs, when we apply them for such kind of applications, we create the segments of the data. So well, this is just a random plot I found on internet. This is not a plot of this particular data set, but the data is of very similar nature. The data we have is just three axes. So let's say these three axes, and we are getting the stream. So what we do is we create a chunk or the segment of that input. We give that to our RNN or CNN or our model, and then we move the window ahead and take another sample, and then we move a window ahead and we take another sample, and so on. So this is how we do the segmentation of the data, and that segmented data is used for classification. Okay, the size of this segment window and the stepping size is very important factor. We usually tune that for the performance, right? In this example, I'm just taking the random values, that is 128 and 32. This is from one of my papers. Okay, you can use any value for learning purposes. Okay, these are actually important parameters, so they are tuned for getting good performance. So the size of the window is 128 right now, and the stepping size means the number of samples you're going to move ahead before taking the next segment is 32. Okay, talking about this portion of the code, I created three functions here in this block. The first one is the read data function. In this function, I'm going to pass the file path of the dataset file, and I'm going to get the processed data frame, the workable data frame or workable variable, which is actually a data frame, to deal with. Okay, so I'm creating a list. That list is named column name, and that list has the names of the columns. So I basically know that which particular column of the file corresponds to what from the documentation of the dataset. So basically, this dataset has this particular file which I'm going to pass to this function has 6 columns, right? And those 6 columns are these. That includes the user ID, activity name, the timestamp. So basically, whenever you sample the data, you put a timestamp to there, which can be useful for various projects, not for this particular one, but it has a timestamp. Then it has x-axis, y-axis, and z-axis value of the accelerometers of the smartphone, which was placed in the pocket of the user. Okay, so for including this data set into a variable which I'm referring as data frame, I'm calling this function of pandas. So I have included pandas as PD, right? And I'm calling the function read CSV. So basically, this function can read CSV files and text files as well. Okay. Sometimes the dataset files have the header names, sometimes they don't. The one which I'm using don't have that, so I set it to none, and then I'm telling it manually that the names of the columns should be set to this. Okay, so it's going to create automatically know that which the first column is going to be user ID, the second is going to be activity. I'm doing this because it makes referring to that particular column easier, so that makes your code better. Okay, so talking about the problems with the datasets. So whenever you play with the dataset files, they have issues. One issue with this dataset is that the last value, the last access value, has a semicolon character attached to it. So that needs to be removed. Okay, and in this line, I'm removing that particular uh, character. I'm replacing that with a blank space. Okay, the next is sometimes because of such issues, the data which is numeric in nature is imported as strings by Python, right? And you have to convert that to numeric data so that can be processed and made used in training of the model. So because the character thing was appended at the end of the numeric data, this z values, z axis value is treated as a string. I'm converting that to float. How I'm doing that, I'm applying my own function. So I set dot apply, and then I write the name of my own function. This is my own function, and this function I'm doing nothing special. I'm just making use of numpy typecasting mechanism. So what happens is each and individual value is going to be passed here. This numpy is imported as np. I'm saying that if the value is none, that returns none. Okay, else return convert that to a float. Simple. As this data set doesn't have any blank values, it's not going to be empty. Nothing empty gonna be returned, and every value is now cleaned that can be easily converted to a float. The next function which I have created is basically just printing the shape of the pandas data frame that will be passed to it. Okay, and lastly, I'm calling this function. Okay, so at the end of this function call, I will be having a variable df, that is a panda data frame, that data frame is going to have a very neat and clean data frame which I can play with to train the model. Okay, so I'm calling a function head of pandas, and this function prints the first 5 values of pandas. Okay, and I'm also calling my own function to get to know that how many columns are there and how many rows are there. Okay, now I'm printing a bar graph, histogram, sorry, and this histogram is nothing fancy. The way I'm doing this is that now we have all the data in this df, right? And the good thing about naming those columns was I can refer to the columns by passing them as indexes, right? So in the activity index we have the labels of the activities, right? I want to get an idea that which particular class has how many samples. So most of the time, especially in the case of human activity nation, we don't have balanced data sets, and that is the case with this data set. This creates an issues in the reliability of performance of the models, but that's a complex topic. That's not a topic of this video. But anyhow, to get the idea, I'm plotting a graph. For doing that, I'm actually getting the value counts of unique values, and then I'm passing that to plot function, and I'm telling it what kind of a plot I want it to be, and then I'm simply specifying its title, right? And it's going to generate a very beautiful looking plot for you. Okay, just simply call plot.show after this. So plt is basically matplotlib. It may have been included somewhere here. Yeah, here we have included it, right? You may have remembered this from the previous video. Okay, moving forward. So basically I was interested in getting the okay, you get the visual effect from here, visual appearance from here, but if you want to get the exact values, usually you need that for writing in your papers. So I'm also printing out the count values here. Next thing, important thing. So as I also mentioned in the last video, in the case of our ANNs and CNNs, we cannot play with the basically we need to give encodings to the labels of classes. Like running can be specified as 0, jogging can be specified as 1, sitting can be specified as 2, and so on. And after doing that, we apply the one hot encoding, right? So I'm doing that. I'm actually creating another column inside the data, inside that particular data frame, and now here the variable label is being used. So I'm making use of a preprocessor in label encoder utility of sklearn. Okay, that may have been included in the upper part. So basically this is what I'm making use of, right? Okay, so here I'm creating the encodings and I'm converting the particular labels into 0, 1, 2, 3, and so on. Okay, right. Talking about now, we have the signal values, and it's good to normalize them. To normalize them, I'm just dividing them by the maximum value. Okay, at the end of this, I'm going to have a normalized values, and I'm also rounding them to 4 digits. Good so far. Talking about creating those segments, as I mentioned in the start of the video, so here is the code to create the segments. uh, uh, so in this function, what I'm doing is I'm creating a segments of all the 3 axes, right? 3 features we have. So so the thing is, it's simply a for loop that is creating at the end here. It is creating a variable segment, and that is basically it's a list that, and it's appended xyz, and another list label is being appended the label of corresponding activity or corresponding segment. So like in first segment, let's say the person was doing sitting, right? And so now you have a segment of the 128 samples, and all that segment you have the label of sitting, right? Okay, so at the end of this function, I'm returning the reshaped segment, which is this, and the label. So basically at the end of this, I'm going to get x and y data. X is the data of input, and y is the label or the output, right? So here you have the labeled output that is going to be 0, 1, 2, 3, basically encoded activities, and the input is this. So basically it's 128 samples of 3 different x's, and these is the number of samples. Okay, so excuse me, at the end of this stage we have x data, y data, that is the entire data. Obviously you cannot use the entire data for training. So for this particular project I divided into 3 chunks: 70% for training, 15% for testing, 15% for cross validation. Well, by the way, I have not making any special use of cross validation, but anyhow I divided the training data, testing data into 2 chunks as well, which is a good practice. So in this code function I'm making use of sklearn's data splitting library utility, and the good thing is it randomly samples the data, right? So you don't need to write some fancy code yourself. You simply pass the data to it. It says and tell it that what the test data size should be, which is 0.3. Basically at this particular block it's divided into 70 and 30, and give it a random seed, which is 42 in my case. So I get x train and x test, y train and y test. So these are the 4 numpy arrays, right? I mentioned in the previous videos, numpys is the input kind of a data that is being used by AI libraries. So after that I'm dividing that 30% test data into further 2 chunks, and again the random part, so it's 50%. So we are going to have cross and test of 15% of the entire data set. You can get the shapes from here. Okay, after doing that, in this stage I'm basically getting the number of classes, the unique classes name, which can be hard coded, but I'm getting that through code. So basically this input is going to be used ahead for plotting a confusion matrix, which is not important for this project right now. Okay, I'm simply again printing the shapes of test and train data here, right, and cross data. Coming towards the neural network part, so basically again I'm making use of sequential, kind of making a sequential model. It's a multi-layer LSTM. The first layer has 32 units, and then I apply a dropout, and then it has another layer of LSTM which has 16 units, and then I'm again applying a dropout, and then the output, right? So this is the kind of a model we are doing here, making here. So important includes are right now just this and dropout and activation. Okay, other are not important at this stage, right? Even not flattening is important. Okay, so I'm creating a function, create function. I'm passing the training and the test data. So I'm figuring out what is the input feature that is going to be passed to the model, which is 128.3, right? Because you have a segment of 128 and that segment has 3 axes, right? So I'm figuring out that from the input training and testing data, basically input training data. So from the shape of this I'm going to get the sample size and the feature size, right? Window size and the feature size, and from this I'm going to get what is going to be the output layer size, right? Obviously output layer size is equal to the number of classes, right? So things are not fancier till this. We just keep on adding layers, and in our case it's LSTM is 32. You can write any number of neurons here. This is telling it the input shape. Then I'm applying activation, which is ReLU, dropout of 0.5 just for regularization. You may skip it for this tutorial, right? And so on. At the return of this function, we are going to have a model type of variable, which is going to be compiled and trained. Okay. After that, I'm printing the summary of this model just to get an idea of what kind of layers it has and what is going to be the input and output shapes, total number of parameters, and then I compile it. Compiling it, I'm telling it that it's going to be a classification problem, so cross entropy loss is going to be there. Optimizer is Adam, that's my choice. I can set RMS prob, anything. Matrix of evaluation is going to be accuracy in our case. Okay, this is a bit fancier than the previous video this time. So basically, so at the time of calling the fit function or fitting or training of the model, what I'm doing is I'm passing the validation data as well. So that is going to evaluate the data on that validation data after every epoch. Okay, so we have the train data, we have the validation data, and then we have the epoch. So basically that's why I divided into cross validation and testing. So for on the cross validation, I'm going to plot the confusion matrix. Then the batch size, it's up to you what you set. Moreover, I'm measuring the time to before training it, so I get the overall time, how much time it took in the training process. I ran it for 80 epochs, right? I changed the code for 20. When you are going to run it, it's going to run for 20. So a good thing, if you make use of this thing, then it's going to return you uh, some history of evaluation done on that training and testing data after every epoch, and you can plot it. You can plot that to get an idea whether your model is overfitting or not, right? That is very useful in actual projects. So we can see that the model is not overfitting. The plot is fairly okay, right, for 80 epochs. After that, I evaluated it. For evaluation, I called the evaluate mod function, and I am getting the accuracy of around 86% of the cross validation data. As I mentioned in the previous videos, you can plot the dataset as well, you can plot the model as well, making use of the utility of plot model from Keras. So that is simple. Just call this function, pass the model variable here, just give it a random file name to save the file as show true, show layers name true, and this is how it's going to plot the model, right? Which is not very fancy, but good for getting the idea. Okay, now again, this is just a confusion matrix part, which is making use of matplotlib and sklearn confusion matrix library. And here we have the confusion matrix. So we can see that we are not having good classification from downstairs, but the other classes are doing good, right? Well, this data set is fairly easy. I have actually reached a accuracy of 97% in one of my projects, and majority of the classification lies here, but this was just a random model, right, for this tutorial. And and that is the case. If you are going to play with it, you're going to get a better performance. So I also plotted, you just can directly make use of this chunk of code which I wrote, and that what it does is it's actually prints a full-fledged summary of performance for you, which includes precision recall and F1 measure. And it also plotted making use of SNS library and give it a beautiful look, which you can directly use in your papers. That is for this video. Thank you very much for staying, and stay tuned. Do subscribe and let me know how I can improve the videos. Thank you very much.